All right, here we are at a very quick section of chapter 2. So basically we went over slope field, and then we went there from slope field to Euler's method and other numerical method if possible. And then after that we did existence and uniqueness. And from there, we actually start to introduce equilibria in chapter 1. Now in chapter 2, what we did is this one changed to direction field. For systems, Euler's method still apply, but you can see it's very, very unstable if you just stay with Euler's method. You may want to try something else. Okay. And the last thing is, again, we want to talk about existence and uniqueness in 2 dimensions or high dimensions. So that's the same thing for systems. We only have one theorem to talk about. Which is almost identical to what we had in chapter 1. So assuming we already have dy over dt, this time it's a vector, equals f t and y. F is a function whose output is a vector, and we have a initial value. Again, it's a vector. Which is given. So we have an initial value problem. Okay. Then, assuming that t0 is the initial time and y0 is the initial value, and the function f is continuously differentiable. Okay. Then there is an epsilon. And the function yt defined for, again, a small rectangle around t0. That uniquely satisfies the initial value problem. So the solution exists, meanwhile it is unique, given this critical condition. And of course, every time we do this, we always consider them on a small rectangle. Let's take back, on a finite rectangle. Doesn't necessarily have to be small. Okay, continuously differentiable. Then this is gonna work. Now if you recall what you had in 1 dimension. In 1 dimension, what you want is ft y is continuous. Okay, and partial f, partial y is continuous. This will guarantee unique. This will guarantee existence. Uniqueness. Now in 2 dimension and high dimension, so we can call 2D. We basically want this one to be continuously differentiable. That means what? That means this is continuous. Also means all partial derivatives of f are continuous, which includes partial f, partial t, partial f, partial your x, partial f, partial your y, because your y vector, capital Y vector, involves 2 variables and the 2 functions. So you basically just require all the functions with respect to all the variables, including t. If you take the partial derivative, it is going to be unique. It is going to be continuous in order to make sure that it exists and unique. So basically from here you can see we just added one more condition. That is, not only this one is continuous, the t part, it also has to be differentiable, continuously differentiable. All right. It's very easy to check. Next time when you have something like this, you just go ahead and try to see all the derivatives and try to see, are they continuous, for example. Let's just quickly talk about it. It's really easy. Like the predator and prey. You have R prime, you have F prime. Let's just do alpha R minus beta RF and negative gamma F plus delta RF. Given some initial conditions, so R from here we can see, well, all the function here, no matter you take the derivative with respect to R or F, and there's even no t, so of course everything is continuous. And because it's continuous, and also differentiably, continuously differentiable, which means the derivative of them are continuous. Therefore, this one definitely have a solution, and it has a unique solution. Okay, so very easy to check. Pay attention to something when you have some 1 over r, which means at 0 it's not okay. When you have something like r to the 2/3, if you take the derivative with respect to r, you are going to have something again on the fraction. That's usually where the bad thing happens. Okay, the implication is, again, very similar to what we had in one dimension. That is the solution of the autonomous system do not intersect each other or each other. This implies two things. The first one is, we did the predator and the prey. We said the vector field give us something like this. That's one solution given initial condition. That's another solution gives you initial condition, and that's another solution gives you initial condition. Okay. So as your initial condition varies, you may have different solution curves. This one guarantees there's no way that the blue or red or black, which means the same differential equation but different initial values, will intersect each other. Because as soon as they happen, okay, starting from here, your solution is not going to be unique. Therefore, they all stay away from each other. What it says is basically the future is uniquely predictable. If this happened, think about it. If this happened, that means starting from this point, you actually don't know which way you want to go next. Suppose your solution curve is going in this direction, right? So the two solutions all goes to here. And starting from here, one solution tells you should go to this side. The other solution tells you should go to this side. Then your future is not uniquely determined. So you only have one future. One possible future to guarantee your reproducibility of your function and everything, your solution and everything. Okay, that's the first implication. That also tells you if you do not have an autonomous system, or if you do not have the ODE which satisfies the existence and uniqueness of solutions, you may have multiple solutions. That's where when you have to deal with the whole thing with more caution. If you think about it, it's pretty easy to think about, actually. If you have f vector, but this time not only it involves x and y, it involves t. Then what's going to happen is, it's very possible that they can intersect, and moreover, even this function itself can intersect itself. Because you can intersect yourself at a different time. So the first time you pass this was at an earlier time. The second time you pass this is at a later time. So from here you can see your solution curve actually will not get confused. You still have a unique future, even if you intersect yourself, because you intersect at a different time. Okay, so the significance and uniqueness of solution only works for the implication only works for autonomous system. Okay, they don't intersect each other. But if you have a t involved, you can intersect yourself at a different time. All right, that will be what we have for 2.6.